everyone, thank you for watching Edupedia World videos. So this is the third part of ABAP performance tuning video, part 7C. We will learn about indexes and their usage. So what is an index and what are the types of indexes we have? What is an index? Index, it supports the search on the table. So using an index, we can search the table fastly or quickly. Okay, so here during a select statement, okay, I have written like select star from table where key 1, key 2, key 3, I have given the values. Okay, so we have a table here with 3 columns. Okay, key 1, 2 and 3. So the select statement is written in such a way that all the entire columns, the values of all the columns are mentioned. It's a fully specified key. Okay, so then immediately we will get the required output. Now, using indexes to limit the search area, 1 fully specified key, single select here. Now select star from table where key 1, key 2, key 3 equal to this. Okay, here also, because all the keys, all the columns in the table are mentioned in the select statement. Okay, when we use the index, okay, it will work very quickly because all the columns, the entire columns of the table are given in the select query and it will give the output. Okay, so this is fully specified key. Now the next one is using indexes to limit search area 2. Now here we have given select star from table where key 1 and key 2, only we have given two key columns on the of the table. Okay, so here it's doing a range scan. Okay, so there will be multiple columns in the table having these 2 values. Okay, so here we have 2 and A, we have 4 rows, so all the 4 rows are output. So this is a range scan. Okay, the previous one is it's a single select, fully specified key does a single select. Here the index will do a range scan. Now the next one is index scan and table scan. So here we have given select whatever it is key, we have given key 1 from table where key 3. Okay, now we have to select only key 1 where we have given only key 3 value, we have given only 1 values of 1 column in the table. So then it will do a full scan. Okay, so what all rows are there having this particular value are output. Okay, so here table scan means select star from table where data equal to XYZ. Okay, so then it will do a table scan. Okay, so just remember, like depending upon the keys, the columns which we mention in the where clause, okay, the order in which we mention, like how many columns which we mention, the search goes accordingly. Okay, so here we have given all the keys. Okay, so it's a single select because it's a fully specified key. In the next one we have given only 2 columns, then it will do a range search. Okay, and in the next one we have given only one column of the table if it has 3 columns, so then it has to do a full table scan. Okay, it does a full table scan. So that's why for performance improvement we have to prevent doing a full table scan. Now what are the recommendations for a proper index design? Make sure that all frequently executed database access on large tables, like whether it's a select, update and delete, are supported by indices. Okay, especially when we work on large tables. Okay, so then the selects, the updates and deletes, whatever operation it is, they have to be supported by indexes. Secondary indexes are created if needed. Okay, so whenever required, apart from the primary indexes means they contain the key columns of the table. Okay, whereas secondary indexes are, we can build them later at any point of stage and drop them. However, primary indexes cannot be dropped. Okay, so we create additional indexes if necessary to improve the performance. The next one is highly modified tables do not have too many indexes. The greater the number of columns in the index, the higher the chances that the updates will suffer. And the tables which are highly modified, okay, where modification operations are very high, so such tables should not have too many indexes. Okay, and similarly, if the columns in the indexes are more, then the performance of the update is poor. Okay, so whenever we create an index also, we should be very careful, like less indexes do not improve the performance, too many indexes also affect the performance. Okay, so we have to create optimal number of indexes on a table whenever an index is required, whether it's really useful or not. Okay, only such indexes should be created. Okay, and primary indexes are created when the table is created. However, secondary indexes can be created and dropped at any point in time. Okay, say like we add a new piece of code to the existing program, okay, or whatever modifications we are doing in the ABAP side. Okay, so when we think that an additional index will improve the performance, okay, then we will create an additional secondary index, okay, to improve the performance of the piece of code. So depending upon like whatever select statements we are writing, okay, so the indexes have to be created accordingly. Okay, and the other important thing is like whatever key columns we will mention in the where clause. Okay, so the index order also should be in the same. Okay, so here we are giving key 1 and key 2. So when you create an index, okay, so we should create an index with key 1 and key 2, not key 2 and key 1. So that order, like how the columns are selected in the where clause, okay, they have to go how the columns exist in the table, okay, or else. And even the index also has to be created in the same order. If this order is changed, then even though you have an index, so here we create an index like key 1 and key 2, not key 2 and key 1, okay, on the columns. So that order is also very important. So then only the search will be efficient. Okay, so that is again important. We have to take care about the order in which the columns are used while an index is created. Similarly, like a secondary index can be created at any point of time and dropped. Okay, and primary indexes are created when the table is created. You can check all these indexes from the ABAP dictionary transactions SC11 as well as from SC14 also. So in these two transactions you can give the table name and we can check what are the indexes which are existing. Now when we talk about indexes, I want to mention one more point here. There can be cases like the indexes exist at the database level and not at the ABAP dictionary. Okay, so SE14 helps us to create the indexes which are there in ABAP dictionary but not in database level. Okay, similarly in SE11 you can create the indexes which are there in database level and not in the ABAP dictionary. Maybe they are not activated. Okay, so an index has to be it's not only created at the database level, but the index also has to be created in the ABAP dictionary also. It has to be created and activated from in the ABAP dictionary. So using this transactions SE11 and SE14, okay, it will help us to check what all indexes are present on that table and we can create them if they are missing at database or the ABAP workbench. Okay, sometimes because when we create the index, the ABAP team, they just simply create in the ABAP dictionary and they miss to create on the database level. Okay, or sometimes from the OS level, where when we log into the database, the indexes probably are created from the database level and they do not exist in ABAP dictionary. So in both cases we will get errors. SAP will throw errors, okay, if there is a missing index at the ABAP level or the database level. So from SE14 we can go and create them in the database, okay, or in the ABAP dictionary, and we have to activate it also. And generally an index is created in the development system and it's transported into the production system. Okay, so these are the recommendations for a proper index design. The main thing we have to keep in mind is like we shouldn't have too less or too many indexes, and the indexes have to be created in a very carefully. They have to be created. The order of the columns which the index used have to go with the where clause. Okay, and the other thing is like highly modified tables. It is suggested like those tables don't have too many indexes. The more the number of the columns in the index we have, the performance of the update will come down. Okay. Now, what to keep in mind for secondary indexes? When table contents change, indexes are readjusted. Slows down database insertion. Frequently accessed tables should not have too many indexes. Create indexes only when that index is likely to be used frequently. Indexes created may not be used to one's liking. Determined by database optimizer by an algorithm, and indexes should have a few common fields. Too many common fields would create problems for optimizer. Use SQL trees for determining indexes. So the primary indexes exist on the table when the table is created, and later at any point of time we can create n number of secondary indexes. But however, a table shouldn't have very less number of indexes, okay, or too many indexes also will impact the performance. Okay, so when the table contents are changed, when mostly depends on the updations, deletions, okay, and the other thing is whenever the headers, the columns are sometimes rarely changed, okay, indexes have to be readjusted. The next one is if we have too many indexes, that will slow down the database insertion operations. Okay, so that's why frequently accessed tables also should not have too many indexes. We have to create indexes only when that particular index is to be used more frequently. Like I have made some adjustments to the program now, so I want to create a new index. Okay, it's not like that. You have to create an index. So when you create a secondary index, you should keep in mind that all the other programs, which means like you have to have a wider area of enhances. Okay, so when we create an index, it shouldn't impact the current operations on the table. Okay, so you can't create an index now and then depending upon your liking, and these are determined by the database optimizer by an algorithm. Which index to choose, this is dependent on the database optimizer. It uses an algorithm, and indexes should have very few common fields. Okay, otherwise the optimizer will get confused. If two indexes have same fields, similar fields, say like out of 4, 3 fields are same, then it will get confused like which index to pick up. And the last one is we have to use SQL trees, okay, to determine like what indexes are necessary. So this is about the secondary indexes. So these are the points we should keep in our mind when we go for a secondary index creation. The next one is the type of index scans. We have a unique index scan, a range scan, and a full table scan. Okay, so in the unique index scan, the entry specified by the index is unique. Okay, so when we say a unique index scan, whatever entry which is specified by the index, it's unique. When we go for a range scan, okay, most frequently a range of values are scanned. A full table scan means no index is used. Full table is scanned for the data. Okay, so we have 3. When we talk about index scans, unique scan, okay, whatever entry which is specified by the index is unique. Okay, so that's what we have discussed about. Okay, so this first one, this is a unique scan. Okay, because this value we have given all the key fields, okay, all the columns in the table, okay, and all the values for the columns are also given, so it's unique. Every row is, this row is unique. Okay, so that is about unique scan. The next one is a range scan. A range of values are scanned. So that is this one. Okay, so select star from table. We have given two columns, two key columns. Okay, so depending on that, a range of scan is performed. The next one is full table scan. Okay, so here it is a full table scan. We have given only key equal to 3, so it has to check all the rows. It has to do a full table scan. Okay, so here there is no index usage only. So when we say index scans, we have unique, a range, and a full table scan. 3 types of scans. Now, appropriate indexes, how to check? Okay, so how can we come to a conclusion like what indexes are appropriate? The first one is code inspector. Check whether where condition contains any field of database index, the first field of database index, not counting the client field. Okay, so when we say like select or update or whatever it is, when we say select star from something, we say where, we should check if any field, okay, the fields may belong to index, okay, and the first field of the database index, not counting the client. It's like sometimes in SAP the client, okay, the client field, the man, it's known as MA and DT. Okay, so that is included in the index mostly for the tables which have the client column. Okay, so excluding that, okay, we check the first field of the index and the first field in the where clause. So whichever the first field of the where clause to which index it belongs to, so that index, so it will check the order of the columns in where, and it will check the order of the columns in the indexes. So depending upon that, a suitable index is picked up. Next one is choose the following single checks: analysis of where condition for select, analysis of where condition in update and delete. Okay, where condition for select it's different, and in update and deletion it's different. Okay, so we have to choose like which type of statement it is. Okay, so that is depending upon the code. The next one is the performance trace. ST05 is the transaction used to get the performance trace. View summary statement. Okay, so trace list, summarize trace by SQL statements after running the trace. So when any operation is running, we can take a trace in SAP. Okay, so ST05 is known as the performance trace. So we will do the summary statement. Okay, so we will go to the trace list, summarize trace by SQL statements after running trace. The next one is count, sort, column, minimum time. Okay, values higher than 1000. Okay, microseconds indicate that these database access may not be supported by proper index. Okay, so you sort on this particular column. If it is higher than 10,000 microseconds, then these access may not be supported by proper index. So this is one layered rule, so you can blindly go with this. And the other one is use explain on these statements to check the access path. So that's what, any SQL statement we have to go and check the explain. Then it will show us like, it will explain the statement like what index is used, what type of scan is performed, and all those details will get. Okay, so using these types of analysis, we can conclude that which index is more appropriate for that piece of code. Okay, so the first one is the code inspector, okay, where we check where the where condition exists. Okay, it can belong to any field of the database index, okay, and the first field of database index, not counting the client field. And the other one is analysis of where condition for select and analysis of where condition and update and delete. What type of statement it is, so select or it's an update or delete. The next one is by using performance trees. Okay, you go to the statement summary, okay, then you sort it on depending upon this particular column, or if it's higher than 10,000 microseconds, then those database access may not be supported by a proper index. And the next one is by using explain, we can come to a conclusion like which index is more appropriate. Okay, so the column specified in the where should go according to the index. Okay, so the first column specified in the where is compared like to which index it belongs. It belongs to. Then it should be the first column of the index 2. And then the second one is compared. So like that, it does a comparison like that, and then it will come to a conclusion that yes, this index we have to pick up. Okay. Now, where we should not use indexes. The first one is negative logic. Okay, in like, or, and for all entries where database is Oracle. Okay, so in these type of, whenever we come across such negations or like, or for all entries in the database, only for all entries, like it's not used when it's an Oracle database. So in these conditions, indexes are not used. Now, how to proceed? If the statement of whatever program is not used or not needed anymore, it's better to delete that statement or program. If the statement of the program is rarely used, then no need to make any changes. If the statement of the program is frequently used or executed, then we have to try to rewrite the where clause so that an existing index can be used. And the fourth type is if the statement of the program is frequently used or executed and cannot be rewritten, then in that case we have to adjust the index design. Be careful, changes on the index can affect other statements or programs. So that's what I was mentioning to you earlier. When we add an additional index or when we delete a current secondary index, so now don't keep in your mind about the performance of your program. That index can be used by n number of programs across the system. So it's very, we don't know, okay, till what extent we can go and verify like where in which program is using this index, which statement is using this index. So that's not in our hands. So that's why the last option is, first we say like modify the code such that the existing index is used. Okay, if you are in a condition that you are unable to modify the code, then only go for the index changing, like creating or deleting a new index. Generally we don't delete, okay, generally we add a new index. Okay, addition of new indexes also sometimes cause problems because the optimizer gets confused like which index to pick up. Okay, so that will also impact the performance of the program. In very rare cases, like if the index is not used, okay, we can check it from like monitoring usage or whatever it is from the database level. Okay, in that case only we go and delete the index. Okay, so sometimes what we can do, we can adjust the index design. The current index we can adjust it. In the other case, we have to create a new index. Here also we should be very careful. Every additional index stresses the database. Okay, so coming to index performance on the query or the statement, these things we have to consider. If it's not used, just go and delete that piece of code or program. If it's rarely used, just don't worry, leave it like that. If it's frequently used or executed, then try to modify your code so that it uses a better index to improve the performance. Or if it's not using an index, then it should be adjusted in such a way that it will use an index. And the last one is, if you cannot do anything to your code, then you have to adjust the index design, or you have to create a new index. We don't have any option. Okay, so this is about this video which talks about indexes. Okay, we have started like how index plays an important role in ABAP performance tuning. Okay, so here we have seen a unique scan. It's a range scan. Okay, then this is a full table scan. Then what are the recommendations for proper index design? Okay, the next one is when we talk about secondary indexes, like how careful we should be while adjusting the current indexes or creating a new index. Okay, then what are the types of index scans we have seen here. Then appropriate indexes, how to check given a piece of code, how can we analyze like this index is suitable for that code. Okay, and these are the conditions in which an index is not used, like not equal to, like, or for all entries. In when our statements have these commands, we don't use indexes. The last one is like how to proceed. Okay, so depending upon the usage of the program, we come to a conclusion like whether the program can be modified or a new index has to be created. Okay, so this is about indexes topic in ABAP performance tuning. Thank you.